basic systems available. And that's kind of what I'm trying to do. I'm trying to do an interpreter at the moment for my compiled language. And the reason why I'm doing this is I'm trying to do compile time executed code, which allows me to have pretty much my language as the metaprogramming language. So I've been working on this for about 3 hours today, 3-ish, 4-ish hours, 3 hours, yeah. And I've already got a basic system works perfectly with integers. I haven't done anything else yet, but that's good enough for me so far. And let's go. And hello, Mikhail, how you doing? Right, let's get some stuff going. So that's what I've got so far to prove that the numbers all work. When we get to a, I don't know, call a procedure, I should be able to print out the result, and the result from looking at this should be 197, and guess what it is? 197. So there we go. So it actually is working. I'm doing some hacks here and there, and yeah, that should be fine. So let's just do that. So as you can see, it's calling all the procedures. So it's calling the main procedure first. It's doing these instructions, then it's calling foo. And the name for foo in this case has been name angle to be main.foo-0. Now 0 means it's the 0th nested thingy bob. That's just my believing mangling convention. It's not very good, nor consistent. At least it mangles it well, and this should be unique-ish enough. Whatever. Right. So what I need to do is I've been messing around this, and I'm not really an expert when it comes to stuff like this. But the thing I want to try and do at the moment is see, as you can see, it's trying to say all the basic types for store when I'm storing values equals string. String doesn't work. So let's look for string is the short answer. We're going to look for, what did I just do there? Store. Let's go to store here. So other basic types, basic string. I also have the other basic type I have is any. So let's do that. Now strings are going to be slightly different. So what I'm going to be storing to is in real memory. So that means I'm going to have to cast it into kind of bytes and stuff. So I could probably just do this version right now. So I'm going to just write some code. So the destination here is a pointer, as you may have guessed. Does this make sense? Yeah, so that is the destination. Wait, is that that doesn't seem right to me. That does not seem right. First, let's just do that. I'm going to figure this out anyway. But what I'm doing is I'm going to first do a string. So the first one I'm going to ever do is a very, very simple one, is this. And this is going to be hello. That is my string for S. So it's not getting rid of it, anything like that. Now what else I could do is when I call a procedure right at the end, I can go through all of the parameters, not all the parameters, all of the locals defined in the scope. And then what I'm just going to do is type T. It's going to be memory, isn't it? Oh god, that's not a good idea. I don't store any memory. So the first one I know is going to be... This is not a good idea. That's not a good idea, is it? So I'm going to go back to main. I'm going to hack this through. I'm just messing around and I can't really... Actually, I could do. You know, I could just use the debugger to view the memory, couldn't I? That is probably a better idea. Nah, let's just do it this way. Let's do the hacky version, man. Hacky version. Or we can just do return values and see what actually we get. Like, the only string value at the moment I've got... result type, what would I get that to be? So, there we go. We're going to get result type, which is going to be T. Proc type, so proc results. I think that is the type. I think. I haven't checked my own system. I haven't done this in a while. Right. No, yeah. Results is what I want. That's the type. So if is type, let's say it's a string, we're going to print out that string. Now the way I've got my values stored is that it's just a weird union, completely unsafe, but that's because I already have all the types here, so there's no point storing them anywhere else. They're all in a compound type. So getting them out is going to be okay. So we need to just do the vout value. This is going to be the result dot data, and it's going to be the 0th, and then we got a count, which is going to be the first. Then what I'm going to do is print a string out, like so, and we're going to try and see if we can store it. That's what the goal is. So the first thing is I need to cast it to be an int. No, it needs to be an I size, doesn't it? Count.val int. And the next thing I'm just going to use it as a whatever, u8 whatever. That's going to be good enough, and that's going to be the val pointer. So we now get a string, and it's going to be blank. It's not finding it. Why is that? Typed string rt. Oh, I'm a numpty. I got rid of the actual thing, didn't I? Like so. So there we go. Now I got a call, and it says this type is string. Apparently, that is very, very correct. Is type string? Says it's string. Says it's the type is string, but when I go into here, is type string. No, it's not apparently. What the hell is going on? Is type string. How many times do I actually do here? I know I'm just doing a printf debug in here, so you can see on the screen easy. Yeah, that'd be called thousands of times. Yeah, that's not a good idea. Why is that not? Basic kind is going to be equal to basic string, and that should be the case. But it's not. Look, it's doing string. That is the type, correct. What if I just do this? This is what I don't understand. What? What the hell is going on here? Let's do our types identical. It should be. What the hell is going on? We're debugging that. What's that? 184. Let's put a breakpoint there. Let's build it. I don't need a breakpoint there. Well, that never get hit. That's not a good sign. Why isn't this? There we go. Now it's doing it. I don't know what the hell's going on there. So let's just see what a result type is. It's a tuple. Oh, you... Of course it's not that. I'm a moron. As many of you may have already known this. Yes, of course it is. Let's first, I'm going to put a little bit of a note for me in the form of GB assert is type tuple. Yes. Let's say if rt tuple variable count, isn't it? Equals 1. If it equals 1, what we're going to do is the return type is equal to the variables type. And then we're just going to do base type, because then... Is that... Have I done that wrong? Hopefully people are understanding me, what's going on here, what we're doing today. Where is it? Tuple. Variables, yes. Entity, type, base type. You're right. So now it says hello. It works, so constant strings work. That is pretty damn good. So we already got, this is literally the value out of here. So we're getting hello for that string, but that's alright because that is a constant value. The question is, what happens if it's not constant? Saying we're going to load it into memory. Did we actually set that up? I never did I? So how the hell is that working? Don't know actually. That is... Oh no, because it's... Okay, it's not being stored, is it? But, let's do a character. Aha, now we've got it. So now it's going to panic on the loads. So other basic types, we never actually put the type in. So let's put type to string type. Let's copy and that paste over there. Let's do that. Oops. So now it's in a string. That is good because we never actually loaded the string in. Now this is actually a good thing. This is probably something done with my optimizer saying actually no, it's not been used, so don't do it. Yes, you really do need a virtual machine to do like compile time execution. Now the reason why, and it's really simple to explain as to why. Well, it's not really simple, but right. We're saying I'm doing compile time execution, and what that means is I apply run or whatever the name is. It might be meta. Probably meta is probably a better name to call it, to be honest with you. But what you do is you do this expression and you run it at compile time. And you need to get the memory to it. So this works. This could just work and you don't need it. You could just pass it through a compiler again and get the results back. And that would work perfectly fine if that was a just like a pure function, like in a functional sense. However, when you want to be able to modify the actual backing code, like saying, hey, can you generate this array up for me with these certain values at compile time, and actually store it like that, you must need some way to access the memory. And this is where it gets a little bit complicated. So what I want to do in my language is be able to have the build system and lots of other parts of the complete tool set, mainly within just the language. You write code and it does it for you. So this is my goal, is I have, this is what I want for building. Basic one, very. So you have like optimization levels, some like bounds checking mode, and then output name and output path. And then what you do is you'd go, here's build options. You'd go in here, you'd write, this is going to be your build proc, whatever, like so. And in build options, you'd write all of the necessary stuff you'd need to set it up. So you'd go optimization level, and then you'd do optimization level like so, and I would say debug. Build, and I'd write build debug here, I would write as well. And I would write bounds check. And I'll just say bounds check mode on, whatever. This would be my thing. And then all I'd actually have to do is I'd say like run the debug build like that. So this procedure gets ran and gets compiled and stuff. And then in the compiler, I read whatever the values are of this build options in the memory that's stored within this interpreter, and just go, oh, so what the person said is, oh, I need to set these like this. You may even have even more complicated things. You might have like branches and if statements, whatever, telling you what you need to the optimizations level. But that's what you need, and you do need some way of reading the memory. And but however, compiling to a file, running it, and then outputting the information to a binary blob file, which needs to be read to another file, is just too slow. And even though it'll probably execute much faster for big files, I think an interpreter is probably better in the long run anyway. So hopefully that should be fine. That's my goal, is what I'm trying to say. Hopefully that makes sense to people. Yes, I know I need to set that up. Now I do have some problems when it comes case basic string. That's what I need to do. So the first thing is I'm just going to cast it to be a uint pointer. So this pointer is a pointer to the memory, if I'm correct, yeah. So this would just be void star memory. That is what it is, and I'm actually going to make it U8. Mainly because it's going to be highly dependent on what everything's going to be. So the first thing is that memory is also going to be what I need to do is, now we've got a value composite things. I'm going to write array, initialize this. I'm going to initialize this with the heap allocator, put in 2 values. And the reason why I'm putting 2 values in is vmap make int. No, not stupid. Stupid built. But then what this means now is I can do array add value comp, and what we'll do is start with the memory, because I know the very 0th element is the data, and that's literally a pointer to the data anyway. But then what I need to do then is go to the next bit. So actually I might rewrite that to be text equals mem plus 0, and then I64 is going to be the count. Actually, that would be data. Let's do count first. So I need to figure out whatever the size of an integer is. Yes, there are templates, unfortunately, but I need that for arrays and maps, and that's the only place where I use templates. Getting a custom array and a custom hash table. But it's fine, and also my hash tables are pretty efficient anyway, so it's not going to be a problem. So what I need to do now is I need to find out the size of an int. So the way you do that is size of int is, I'm just going to go vm type size of int, so tint. This is going to be how many bytes it is, which is great. Let's go to len. No, this will be the count. Data is going to be data, the mem, plus whatever the size of an int is, because that's where it is. It's going to be 1 plus the size of int. Actually, let's make this a bit more clearer. like so. I'll just probably make this a bit... So I'm just trying to... I don't know why I'm neatening this code up already. It makes no sense whatever to do that. So now that I've done that, I now need to switch on the word size. Case... if it's 4, that means now the count is I'm just going to cast that to be an I32, count data, and then dereference it, and then break. There'll be one for 8, which would be an I64. This is where I'm getting the data from. And then I'm just going to do default and GB panic, unknown, int size. I'm only going to support 32-bit and 64-bit at the moment. So hello, it worked. And look, it loaded the string correctly. Which is great, actually. Absolutely great. So we got hello. C is the only thing we haven't yet calculated. So to prove whatever C must be, I'm going to put this in another function, by the way. So I'm going to call this bar. Return it as an I64 for now. Return Y. And if I go to the call procedures, we can do a little bit more of a hack here. If is type integer, that's fine. Oops, so we're getting a crash. Okay, unknown value. Ooh, this is. Ooh. This is a compiler bug. Okay, that's really good. No, that's really good. We need to go to build. 198. Unknown entity. So it does know the entity does exist, but it's not been found. Because it's probably not been added. Because it never probably get used. Yeah, none of them get used. So... that is a bug, but not here. That's a bug in code generation. Now the reason why that's a bug is the minimum dependency map isn't being generated correctly. So does it actually depend on that? So how do I know what dependencies are? Let's go to where the definition of that is. We're looking for all the entities. First, no, we're going to add all the ones in the global scope. That's what we're going to do. Then we're going to add wherever the start position is. So we've got a node. We're going to get that. Okay. I'm going to get hash node declaration info. We're going to look for all the dependencies. Add dependency to map. Okay. So what dependence? Why does it think foo and bar are a dependency even though they don't ever get used? That is bizarre. Because they don't get used, so there shouldn't be... I'm just going to... You know what? I'm going to do my favourite thing in the world. That's not my favourite thing in the world. Well, I'm lying. Oh, I'm a big fat liar. That's why that doesn't work. It's missing an asterisk. There are all the things. Decal dependencies. There are all the dependencies for that. Let's see this. So, okay, there's a bug there. So now it's probably because there's nothing there at all. Which is surprising, actually. So let's just... I'm trying to figure out... Why is my dependency mapping going bizarre? So it is a dependency mapping bug, I think. So what I'm going to do is just copy and paste all of that. And things do pop up multiple times, that's fine. So let's look for bar. No, let's look for foo. Oops. Turn the speakers off so you can hear me. Is everyone hearing me perfectly fine? Just checking, is everything fine? Just, I don't know. So I don't think it's the dependency map. Well, it might be the dependency map, It is the dependency map. I'm a numpty. No, I know where I've done it now. Let's build procedure. And then... what I'm just going to do is print out every procedure that I can. For every I don't care about the crash there, that's fine. So everything's got here, that's great. If the procedure, where's entity? I'm just checking, yeah, it is entity what I wanted. Entity type. Is anything in there procedure-wise? No, it doesn't tell me anything about parents, which is good to know. I can't remember how it did me on system. I'm also quite tired. It is technically 11 o'clock BST. That's what I'm running on because it's now GMT, isn't it? So... let's actually look at the scope. Because the scope will actually tell me. If scope is procedure, we should still get most procedure calls. No, we don't. Aha. This is where the bug is. No, this is perfectly fine. It is my dependency mapping working as I expect. Just not what I was expecting. So look, procedure declaration. If it has a body, that's fine. But we don't have a I don't have a module bit here, do I? So now I've got that going. So, yeah, that makes perfect sense. So now then what I need to do here, when we go to CodeGen, we need to put that into module. There we go, it's fine. There we go. Oh, that's good to know that I've now fixed that up. That was a weird bug. I knew what the bug was, I just couldn't figure out where to solve it. That took me it was a bit slow. I got it in the end. Right, let's go back to where we should be. So we don't call any of them, but we will do now. It's called bar, and we should get different values. Bar is -196. Is that what we expect? Well, let's just play it again. We get the same value. Let's go through the code. So S is going to be, there's just some random parameter put in there just to test if it does everything. We get hello. Now with hello, we get the 0th element, which is going to be H. Now H in ASCII is, let's just get an ASCII table up, I cannot remember. Capital H is 72. Yeah? So this is going to be, if I look through all the code, X is at the top there, is 123 plus 2 minus 321 plus 72. Now what we're getting here is the question. If we get that's 5, add 2, we get 0, add 7, that we get 9. So there's that bit. And do we get, I'm going to calculator up, I can't be bothered to do mental maths in my head right now. We don't get the right answer. What's gone on? There's something gone wrong here. Let's check if it is the load. It is the load. Let's just check it anyway. So let's just, do I ever get here? So GP panic. Yeah. And then we're going to pass in that data. And that's not GP panic, that's GP printf. That's just a blank string, apparently. Is it? Is that a blank string? Really? Yeah, it is. Okay, that's good to know. So why is it that am I getting a different number? Is that what I expect? Let's just say, actually, we'll just say return. 1, 2, 3. Yeah. Let's say that we get is 0. Ooh, there's a problem. At least we're finding out the bugs, is what I'm trying to state. So in code, what does this actually look like? So origami, create plane below. Let's look at the code here. Yeah? So let's look at the main code. What we're doing here is calling bar, and that's it. And store it into X. So now we're going to bar 0. We do some complicated stuff. Let's make this a little bit simpler. And do that. Yeah? So now that I've done that, where is the C bit here? So initialize that to 0. Then I'm going to load in the string. Just load the value of the string here, so it's just values, and then extract some values. I've probably got some extraction values wrong. Yeah? Might be the problem. Might not be, I don't know. So let's look at its extract value. Where have I actually did that? I hope people are following along. Well, not programming, I'm just understanding this. So let's look at struct extract value. This is where it is. And again, here, yeah, it does get called. And what I need to do is do the type. So type to string, SSA type of the value. And it should be string. I get a U8 pointer. Is that correct? Oh yeah, because the value itself is that. But if I get the address, it should be pointed to string. No, it should be just string, yeah. If is type, let's say it's an integer. No, so let's say it's pointer first. That. Then what I'm going to do is just pass in the pointer. We do get a pointer, and it should change every time. That's great. Let's say else if is type an integer. LLD file int. I get 0. So something's gone on. How many characters is hello? 7. Oops, 7. Is it really? No, I was right the first time. It really is just blank data, isn't it? So why is that? I'm trying to figure this out. I again started it today, trying to figure this out. What is going wrong here? So we're loading a string. We only get 1 here, so that's good. So that means we know this bit works. Now, because we only get 1, oh no, it's the only bit here. It must be this code. So now let's look what this load actually does. I'm allocating some new memory and then appending to it here. Let's see what I get. So if I'm getting the data, if I've got memory from this pointer, is that the correct pointer? Or do I just want that? No, I was right. Unless it's value pointer. Yeah, I'm going to get the wrong value. So it is. I was right the first time, like all the rest. What don't do. IO looks so weird. Yes, it is extremely weird. This is. The main reason is it's extremely type safe. Well, it's got loads of types everywhere. You get used to looking at it. Like So, right. What we're going to do. So, looking at the load. Oh, hello. Arc0RE1. I don't know how to pronounce your name, sorry. Right. So. I have an inkling that this isn't the bit that's wrong. I have an inkling it's the store code that's wrong. Yeah. Oh my god. Yeah, look, I'm a numpty. Look, the reason why it's all 0 is because I never actually did anything to it. Ha. Clever me. I'm very clever. So the destination is just going to be... it's going to be a pointer to the data, isn't it? That's a pointer to the data. So now that'll be the mem first. And now we just got to do the exact opposite of that. That's what we need to do. But in this case, we don't need to store the array because it's already there. I just need to go now the exact opposite way around. Okay, no, that's good. That's good. Good. First, we need to just do mem doesn't equal null for now. No, GB assert. So where's this crash happening? Let's go through the debugger. Here. Yeah, it's a double cast is what I need. I didn't need to do that. I need to do that. Mem equals 0. Is that really the case? That's not good. So the first thing I'm going to do is actually ignore all that and just completely print out the strings. So what I should get is data, val, that should be do that, and that we should be val pointer. I'm going to cast that to be a U8 count. Now I know this should be correct to ish. If I do that, I should get hello. No, I get I get a different string. I get that string first, which is the printf style stuff. No, that's good. So now I know I've got the data from that string. Now we need to store it into that data. So looking at how I store, where's the only other time this gets called? Well, it's in here. So I pass the address, which is a pointer. I don't know why I'm passing a pointer. Oh yeah, because I could just cast it across, can't I? That makes more sense. So now the destination, this will be a pointer. Let's just put mem in there. What am I missing? Semicolon there. Yeah. So that's the pointer to the memory, is it not? Just thinking this through. Yeah. So this should be the actual raw memory. So I should need to do a mem copy now on that. And then I also need to do a mem copy. So what I need to do is the word size plus the word size. Do the count. Let's do that bit there. I know what I'm doing now. Maybe. Who knows? Maybe me? I don't know. Let's mem copy from the word size across. And then we're just going to nope, that's meant to be 8. 8, and that'd be 64. Count, that would be, I need one, it would be word size, won't it? That's what I need to do. And technically they would be word size. And I'm getting 72, which is the correct number now. That is really good. So I was just doing it wrong, was the short answer. You might have been able to guess that, but Now the only problem is I'm actually storing it. I'm having to count do that because I'm just worried about think this through. I think I need to just do a store an integer there. Destination value count, let's do count 64, and then word size, let's do that. That might be simpler. How did I store an integer? Destination was just destination, val was just val. Let's just actually do that then. Oh, the VM value. Let's just say it is that. It's probably not. So that works, and we get 72. If we go to the next one, should be a different number, yeah. Let's go to that. Should be 72. Yes, okay. All that works correctly. Isn't that great? We do the exact same thing for a basic any now. Let's just do that. Now, how was an any type structured? Type info first, then raw pointer. Okay. Okay, that bit's done. Right, is anything else I need to worry about for now? yeah, there's probably all structure stuff. But now let's try and do a bit more complicated stuff. And what I was going to be talking about is a little bit more complicated. Let's look at the instruction. Oh, is I'm disabling the runtime instruction, which is this bit here, and it's going to crash like mad, saying, "Hey, I haven't handled external procedures. Could you do that?" So shall I work on external procedure calls and see if I can actually even do that? It might not work. We can ignore it for now. Or I could do loads on procedures. You know what? Which one should I do? Shall I get... Actually, no, I need to do both, don't I? Let's do the simplest version case first. Let's do a vector2. Like so. Yeah. Let's probably do that. I want to see if that actually works first. Okay. I haven't got a store for that yet. Okay. Type struct. So everything is a struct, so technically even the raw union and the union, they're all members is what they are. Yeah, so what I'm going to do there is actually do this. So get ignore enums for now. No, these would be all record, won't they? Aha, that's how I changed the system round, didn't I? I remember doing this. Records. And the way I need to do them is go for if the type is struct, else GB panic. Let's just do that for now. So if it is a struct, let's do this. Let's go to type record, and what we need to do is we need to get each element out and get the offsets, copy the memory in, and do it that way around. So it's pretty much this, but on a generic scale. Field count I++, entity F for field, like so. Now what I'm going to do is get an offset. So I've already got a little bit set up for that when I wanted to do this. Field so we've got the base type and then the index technically that index can be doesn't matter, just whatever. So that gives me the offset in bytes. So now I need to get the data first. Let's do that. And what I need to do is get the hack member memb plus offset, we'll cast that to be that. And then what we're going to do is pass it into this again, which is very simple, isn't it? So we go VM member, which is going to be the destination. The value will be the value is going to be val comp I, and then the type is just going to be whatever f type is. So that, okay, we've got an array out of bounds thing going on. No, that's good. That's good. Probably not field count is what we want. Wait, that's correct, isn't it? That's where the bug is. Let's write the message. I bet it's 0. It's 0. That's because we actually haven't handled the value. It's just got a null value. Max count. So GB, whichever's the max, no, whichever the minimum. Field count, whichever's the minimum out of these two, which either will be doing that. It could be that we've got none. Let's. Okay, that works better. That's better. Let's do that. And I'm also going to do, actually I was going to put this in a procedure. And I'm going to just return ints, whatever. I know these aren't ints, but this is where I'm going to do the casting. Okay, that never gets called. Now it does integer 0. Okay, that's good to know. Because it knows that, again, none of these values were correct because we never actually got a constant stored for that. Even though it was a constant, it wasn't a constant structure. We never did that. We did compound arrays. Never did compound anything. Right, so what I'm doing is, sorry if people aren't a little bit confused, I'm just going to Milton and actually explain this a bit better. Actually, where is? Oh, it's over there. I was trying to look for my pad to write things down on. No, not pad, it's the... What's it called? Wacom tablet, that's what it is. Right, so what I'm doing here is I'm adding an extra step into my compilation stage. So what I have is usually have the front end, like so. So the front end is handling the tokenizing, it's doing the parsing, and I've also got the checking going involved. Yeah? That's what the front end is. I add another stage in now, and I'm calling this the middle end. Yeah? So the middle end is what I'm going to be doing is, it's kind of, I'm going to just do this in red. So I've got, this is going to be the compile time. Actually, you know what? Let's call it run SSA generation. I haven't got this stage gen. So then it will go through the interpreter, which is for this. Then it will go through the main SSA generation, both of these have, then it will go through an optimization stage for me. I do an optimization stage on my end. Then my end stuff. Then we've got the back end stuff. And this is LLVM, SSA to LLVM IR. IR, we're going to pass that through opt, which is to generate the bit code. I'm going to put it through LLC, which will generate the object code. Put it through the linker, and then you're done. So that's what I've got. So SSA this is what a lot of modern compilers do, even though it was invented in the 80s. SSA stands for single static assignment. That's what it is. Single static assignment. Like so. That's what SSA means, and it's just easier to say. This opt here is just one of the LLVM tools for optimization. LLC is the LLVM compiler that will turn its bit code into that. And the stuff in red is the stuff I'm working on today. And it's actually what I'm mainly working on is this bit here, which is the interpreter. Now, SSA is this. So this is what LLVM does. And SSA is single static assignment. So it's kind of like generating a bytecode where only each value, you've got infinite amount of registers here, yeah? And they are constant, so you can't change them or modify them. If you need to modify data, you need to use alloc, which creates memory on the stack, or you do it in global memory, or use whatever. You need heap memory. So that's what that does. And SSA is kind of the intermediate representation. So this is used for doing high-level optimizations everywhere. And you can do a lot of code, so you can cut down and stuff like here. I'm doing some optimizations on this code, so let's get rid of some of them. Is it under opt? Yeah. Let's put it here so it's a bit. Put this here, and you'll see what happens. I've got some mild optimizations that I'm doing, which I'm going to get completely rid of. And what I'm going to do is that. Completely no optimizations, and you can see what's happened. I've got my naive code. This is actually it was two different blocks. This is one block, and that's another block. And that's what it's doing. So it's merging, it's getting some extra instructions here and there, doing all that. So let's put that optimization back in, because it's still not doing many of them yet. I've only just kind of got the framework for it. So you see it's just fusing blocks together. So as Drunk Dane is asking, Mikhail, he's asking what is type info. Now type info is this thing that's in the preload, which is part of the standard library needed runtime. Type information, this is the actual type information for what you need. Literally that's what it is. It's just type information. Now, this stores all the type of information for every type that you need, every time you need to get generic type information. So it's got name types, it's got integers, floats, any's, strings, booleans, whatever. And it's got all the information you probably want, and some bit more. And it's what you can use type info for is introspection, reflection, type safe printfs. So if you look at printf in fumt, I'm passing in any type which stores a pointer to the data and the type information, pointer to type information, and so it's all type safe. So how did I learn LLVM? Mainly through just reading the documentation, literally that, and also looking at what LLVM actually generates from my C code and do it that way. And how to learn compiler design, I literally just looked at other people's compilers and see how they did it, and learnt from there, to be honest with you, because it's very bizarre. So what I'm trying to do is no, I'm not interpreting the byte code or the bit code or whatever it's called. I'm interpreting my SSA, which means I'm going to have to do something funny for phi nodes when I get to them. So I'm doing it very simple. I'm just doing whatever I need to do to get this to work. That's all I'm doing first. Else, if type is a structure first. I'm missing a semicolon somewhere. Oh, else if. So that's what I'm doing. It's just, this is passing the SSA. How much optimizes it? LLVM does a lot of optimization. You just set what you want to do. But, okay, this is a crazy thing. Okay, this is really quite crazy. I was having this thought the other day and I was thinking, great, I might actually just get rid of LLVM in the end. Because if I can do a lot of my own optimizations, because mine are so much faster, literally because I don't have to write it a file, then it has to pass it again, then it does all the stuff. So it's like you're wasting about 80 milliseconds doing that. So instead of doing that, why don't I just do it myself? This is a crazy thing. I'm not going to do this for a long, long while. Just go through it. And so yeah, I've got my own little optimizations, but they are so basic that they're there just so I can easily read things better, so it gets rid of the clutter. But the other thing is my optimizations are, what are they called? Sorry, and also I'm just relying upon LLVM for all the optimizations really, but who cares for that now? So now I'm trying to think this through. How did I actually do the printing? So I'm doing a lot of cheats here, so I've tried to make it least LLVM like as possible. SSH text. There's a compound element. So this is generating one I need to do. So I'm going to start with is vector. I'm not done vectors yet. Is struct. Let's do struct. And it says I've got some temporary arena memory. Do I actually use that? Do I use an allocator anywhere? Why have I done that? I don't know. So let's first do this. So let's go to is T already a base type? No, it isn't. Let's just do base type 2. So this will get me a record, because that's what they are in this language, internally at least. Then you've got the value count. So now I need to store a lot of values going on here. So I need to do is we've got the result, value comp, array initialize, that's value comp, like so. That's what I'm going to do. And also we need to put a heap allocator in there just to store the memory. That should sound about right, yeah. Array initialize. This may turn out that actually it's got loads probably going on here. Yeah, I can write loads of programs in this language already. I can do anything that C does. I'm just trying to do the metaprogramming stuff today, which is why I'm trying to do it. If I get this in the language, this is literally better than C. That's what I'm trying to say. It's like, hey, this is actually better. So hopefully I can completely replace it. But I'm not stopping there. This is the first stepping stone to doing a lot more, and I mean a lot. And some of it's going to be crazy, but awesome. Crazy awesome. I should probably make a better initializer there, but oh well, doesn't matter. So now I'm going to do this here. So standard library is still minimal, but you can just use C standard library. It combines C efficiency. Yeah, it is literally as it will be as it's as low level as C. It's not really any safer than the C either, but I don't really need the safety. So I can set that to be null, can't I? Which is good. But yeah, that's what it is. Yeah, I can keep the LLVM part optional. Like, literally, you could set in your program and just write, say, hey, use the LLVM backend if you want. Or if it's just change what the background backend to be or whatever. You could even compile to C. You could compile to assembly. You could compile to even back to this language if you wanted to, for some bizarre reason. You can do whatever you want. It's not really... that's not really the problem, if that makes any sense. So M in this case is VM module info. That's great. So now this allocator here, that's what the temporary allocator was, wasn't it? But I never did that. VM allocator for now. Let's just do that. Okay, so we've got an array out of bounds somewhere. But what's gone out of bounds? Let's just go in the code. Exact value. So we got something out of bounds. Here's the out of bounds bit apparently, which is LMs. Count is 2. I is 2. Ooh, oh, look at that. Value count is stupidly stupid. So something's gone stupidly wrong. Have I got the wrong type, is what I'm trying to state. Yeah, I've done that wrong. There we go. So that should, touch wood, be better now. Should. So don't keep your hopes up. So, for some reason it's still saying 0, which is not what I'm expecting. So now let's go to store a record. Now I know what types these should be. Should, I state. Let's do that. Let's make this actually an I32 for now, and that's an I32, just so everything's a little bit easier to work with. And actually, no, let's make not an I32. Let's make an I64, just for the hell of it. I'm just why not? So let's go to here, and let's go there. Let's just run that and see what happens. We get 1 and 2, which is actually what we want. But this is where the funny thing happens. Does that memory get stored? Does it, is the question. And actually, come to think about it, I probably might get rid of the destination bit and just change that to be a void pointer. Like, it's clearly memory at the end of the day. And do that. I have thought about it, but writing the Odin compiler in Odin would just be masturbation, really. That would be pretty much what it would be. It's not actually worth it. I'm not going to write the compiler in that language until... sorry, I won't write the language in the language until like version 1.1. So when it's completely stable and actually pretty useful is what I'm trying to state. Oh, I'm going wrong here. So yeah, it's no real point. Why waste my time is what I'm trying to state. I shouldn't need to do all these stupid things going on here. So right, let's go look at this. So now we've got... So where I need to go to is store integer. So now we're doing that into that, aren't we? In like that. I'm assuming little endian here, that's what I've said, because if it's big endian you'd have to swap it all around. And yeah, do it by byte by byte. So what I'm going to do here is I'm going to assume it's if store bytes equals 8. That's why I've done that. Let's do i64i destination. Cast that as an i64i. That what I need is a bit cast is what I'm trying to do, and just do that. LLD, not TD. And I am getting valint. I'm getting, okay, they're all getting stored correctly, so they are, that piece of memory is being stored. So where is the store instruction? Here. There we go. So that looks a little bit better now. So is getting stored into V. Now let's get rid of that for now. Integer says 2. Integer says 1, 2, 3. So now structures are storing their values correctly. Saw how great that was already? This interpreter is already getting good. Very good, in fact. I haven't got fine nodes yet. Probably just disable them in the compiler. Unreachable will be a panic in the compiler, so I don't know how you should handle that. Have you got any unit tests? No. I'll do them later. Like, I don't need them that much yet. I've got actual programs which I can test, which make them work. But I'm trying to do really simple things and build upon them as I go along. Unit tests aren't usually that helpful. Even making a compiler, they're usually not. This quotient thing I need to worry about is because I need to do the bytes correctly. And the floats as well. Test-driven development, no, that's bollocks. Honestly, that's just complete bollocks. Honestly, most of the things that you want to test are untestable. Literally, that is kind of a proof. So, yeah. Right. Okay, let's go through this. Now what else do I need to do? It's not bad, look how, because it's a really reduced instruction set, it's not much code. That's like 838 lines, that's really is. I haven't done the vector stuff yet or anything like that, or vector shuffle bounds check. But yeah, it should be fine. What time is it now? Yeah, I'm fine. Rightio then. We'll probably go for another half an hour or so, can't we? Yeah. You can see what I'm doing here with like 0 in. This is great. Yeah, like you've seen some of the bugs I've had, and you've just seen one of the bugs I was trying to solve. From a unit test wouldn't have helped really, and even I just found it. It took me about a few minutes to solve anyway. This one here, this is a good. This little example here is good enough as a unit test, and it's telling me all these problems here. So one of the biggest problems I've got is to do. I haven't got other constants as file. So what is file in this case? That should be OS. File is a struct. So it should have handled that actually. Or is that a load I'm looking for? So store to do other constants. Really? Exact value. To do other constants. Yeah, apparently that is another constant I need to do. Let's say if it's a record for now, just keep it simple. Or is type array, or is type a vector. Let's GB assert that, because that should be the case. Type is a record. It should be a record. So we've got a crash here. So what type is it actually? Insert message. No. There's when you're talking about if you can't test, it's likely design flaw. No. There are some things that are physically untestable. Like literally, you can't test them. It's a proof in mathematics actually, so I won't go into it. It's not worth it. But this looks like a Rust knockoff. It's more of a JEI knockoff with Go in there and Pascal mixed in as well. And that's what it is if you already want to know. But hey, it works for me. And I'm liking it already. There are some things that should be tested. I'm not saying you shouldn't do tests. I think you should always do tests. But I think unit testing there's only a certain amount of problems which it's good for. This is looking more like JAI. There are things I don't like about JAI already. But hey, I've got some other crazy ideas I'm getting up soon, which may sound crazy. I'll be right back. I've just got to go do something for a second. Okay, I'm back. And okay, bacon drinker, yes, I know what you were talking about, and that's what I was referring to as well. And it's a really big, long discussion, but personally, yeah, I don't think unit testing is that useful 99% of the time. Sometimes it is. That's my short answer. So let's get back onto development if I can. So why is it? Okay. It hasn't handled a file, but which so let's go to the original type here. And I don't need to do that there. T, 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 T. So, whereabouts is that actually popping up is my question. 3 places where it's a file, and I'm calling an external procedure. I haven't handled other types for array store. Other constant types. This should work, I think. Else. I'm just going to do a panic here. So, yeah, it's not the panic. Other compound types. But as you can see, I'm always testing things. Like, I'm adding little things as I go along. So my little demo, in fact, is I'm adding little things just to test if they see it and it works. Okay, great, carry on. I'm not doing anything big with my tests, so that he's also gone now. Oh well. But yeah, that's kind of what I'm saying. I'm just doing little things as I go along. And this is all I need for this, at least. By the way, I'm thinking of changing the syntax for type literals to that as well. Mainly so I can get the syntax for procedure literals to be the exact same thing. Procedure calls, so function procedure calls. So that means I can have any order arguments, which only works if you call all of them except the ones which may be optional. If they're optional types, you don't have to pass them. So that will work, and they'll just pass to null. So actually, I think it would be a better idea. And you don't have default types; you just have optional maybe types, as they're called. So yeah, that looks good. So why is it I'm doing an array here? Let's do value. Let's do an elem. Here we go. So there's something going on, is my question. What is going on? Is it this bit which is here that's being caused it to do other constant types? And it's on line 313. So I'm just going to build it again. Escape 313. Oops. Yeah, there it is. And, oops, I didn't mean to. I meant to add a breakpoint right there. Am I pressing the wrong button again? Yep. What the hell's going on here? So, how did I get in here? Yeah, I came from the array. But I guess in this case, even though it may be constant, even though it may be an exact value, it's still got to go. Oh, it's compound type still. Okay. We're going to here, the value is now invalid. So, when it means it's invalid, it doesn't mean actually invalid. It just means entity, no, exact value, invalid, return, result is just going to be null, whatever. 0 value. Okay, so I'm missing a store when it comes to procedures. Got records there. Case type array. So first we need to get the memory to the array, and that would be a pointer to the memory, which is fine. So that means now, yeah, that's what I need to do. Is I now need to go through whatever the comp count thing is. So this would be the element lm count. Let's do that. This is this. We'll do 2 I64 whatever. Yeah, sometimes I even did OpenGL demo in this language. I can even get it up and running if you want. I just want to finish this bit off. lm size is type size of, oh no, VM type size of t, where is it, t or type, array lm. So now we've got array size. So now we're going to do this. So now we need to do, we've got the pointer, we've got the array size, we've got the array count. Yeah? So now I'm going to do the exact same method we've done here, but instead of getting the offset, we already know what the offset is, because that'll be the memory element size times the element count. We don't need the entity, and we know what the type is, because it will be array.lm. So this will be the lm type. I'll just do that. Like so. So let's make that nice size. Make that nice 64 actually. So that's what we've got going on. I think that might work. That should be element count, not field count, and that doesn't make any sense. That's going to crash. Wrong element count. Type array lm. Or is it just count actually in this case? Yeah, just count. So we're now calling an external procedure. So actually this still works. So we need to go back to the instructions. And comment that out. Let's do an array. Let's do 3 ints. And actually what we're going to do, yeah, it's like that. So we do, it's going to be that 7, 4, 2. That's good enough for me. And actually these are going to be int 64s. That's going to be a want element. And what we should get is integer 2. Is that correct? I haven't done a load of a structure yet, have I? No, I haven't. Ugh. This is going to be fun. Oh, great. That'd be just a void star, isn't it, for that? Oh, no, that is correct. No, that doesn't look right, actually. No, I wrote my entire own parser because it's not that difficult, to be honest with you. So What we need to do is be type record, won't it? If is type struct okay, so now it's saying I need to do that one. So let's go into here and figure out why it's not loading it. And actually, how would I load it is the question. So what I need to do is create a new array, like so. And the values that I'm going to do into there is going to be the type record field count, which makes sense, yeah. Record count, field count, yeah. And I'm going to resize it. That just gives me the capacity. This will now give me the actual full size. Yep. So field count equals whatever the minimum between these two are. So it's loading. Actually, no, that will make a difference, would it? So now we've got the field count. We now need to go through each piece of the memory and store it into those values. So it's going to be mem pointer cast that as a U8, so we can do all that lovely jubbly stuff. Then we're just going to go for I size I equals 0, I is the field count, I plus plus. And then what we're going to do is just go through each of the records, the fields in there. Yeah. Type offset. We're going to pass it in the base type, and the index is what we need, and that will give me the offset. Data is going to be mem plus offset. I'm now going to do VM value. Val be good enough for me. Data, actually don't need to put that in a variable, do I? I can just put that there. And the type is that. And then what I'm going to do is go to val comp I equals val. So actually what I'm going to do here, instead of v, it's going to be result, because v is a little bit bland. And I could easily rewrite that accidentally. So, how does my VM work, virtual machine? It's weird. Sorry, I know that sounds daft, but it's the best way of explaining it. I'll explain it actually a bit more clearer, don't worry. Right, so where's the crash happening? Loading that integer. So I was mildly wrong going on there. Yeah. So there's something going wrong here, because I actually said it had to be that. Which makes sense, but it's not right at all. Sorry, why is that? Because to be honest with you, I'm going to have to change how my Bleeming thing works, to be honest with you. Because what that does there is it's just storing a pointer, isn't it? So that is a pointer to the data. Yeah. So that should still work. Let's ignore that. Yeah, that should work, is what I'm thinking. Yeah, each pane, each each view has its own tabs, so I can go like that, and I can just scroll across them all, whatever. I can even pop up other panes if I wanted like that. So that's one way of doing it. But yeah, Sublime Text is quite a good editor. It's just, yeah, it's fine, really. So it does actually work. Okay, what I did was right, so now I just need to do that. Okay, so there's a crash going on. So we got that, and why is that crashing? Where is it crashing is my question. It's loading the integer. Is that a valid pointer in memory? I don't need to write cast. That's my syntax. That's going to be 0, it says. Yeah. So let's dereference that. We get null. That's not good, is it? The main reason why having two separate views is that I can literally swap between them with the keyboard. It's all the keyboard options there. Having separate windows is more complicated. It doesn't work as well. So that's the difference. That is just bizarre what I've just done. I'm trying to figure out. Do I actually need to do that? So, I'm sorry, I'm just trying to figure this out. Why my load instruction is... There's my problem. Actually, that is literally my problem. I've solved it now. So yeah, I was right. This was simpler than I was thinking. So, let's put X in there. It should be 7. We're getting 0. This is not good. At least it's working out better than I'm expecting. Let's do that. So, this means this isn't getting initialized correctly, which is a good thing, weirdly enough. Like if I do this, I'm getting 8. So it's just the initialization of that constant. That's all that's wrong. Okay. exact value. Let's resize that array. So I think the problem I have is actually, what's the problem? It looks like it's a load that's the problem. And I don't actually handle arrays, do I? Or is it a store? Yeah, I do handle the store, but not correctly by the looks of it. So I don't think I'm getting the right memory by the looks of it. Now, luckily I know what the size of that memory is, and it's the only place where there's actually this gets. I'm going to just make sure I'm writing here. Yeah, it only gets called once. Let's do a hack. Don't do this, kids. You're not kids, but you know what I mean. Mem I64. If this is correct, it should be 7. No. So what is that? It's some destination, it's a pointer to the data, which is the first thing. I'm getting 0 every time. That's not a good idea. That's not good. Is it? What about the element count? Like so. So I'm getting element count to be 0 in this case. So is that really a 0? Is that? I'm guessing it's this bit that's a 0. Can we just check to see if it's also a null pointer? Because it might be a null pointer as well. Yeah, it's a null pointer. So this array doesn't actually get initialized correctly, which is in the exact value stuff. It's really big. It's hard looking at big text. I usually have it this small, but most of you on stream will not be able to read it. It's half the problem. Um, 7, 4, and 2. So it is actually doing it. So this bit is actually working here. So it should be storing it in that value, which I'm guessing it is. We've got an exact value. probably don't need to do the store integer. Yeah, do it there. And get rid of store integer now. Okay, that was a bad idea. Shouldn't have done that. Actually, it did make more sense to separate it out, didn't it? So why is it that they aren't going to be stored? Let's just do a hack again. Let's say we call them 1, 2, 3. It's this point here. I think the pointer's wrong, but it's not. Let's just do that. No, I was right the first time. I don't know why I'm doubly... Something's going on here. Oh, you big old numpty Bill. There's your problem. Why did no one shout that out? Like, I wasn't doing the stride correctly. That's the problem. And now it works. Now it works correctly. Yay! Yeah. Vector's going to be a little bit more difficult because how LLVM does their spec for booleans of vectors is that they're actually bits stored, which I think's stupid. But yay, whatever. But oh well, whatever. That works like that. I'm going to commit this now, so what am I going to do? I'm not going to have the dying call stuff yet, just in case. So what I'm going to do here is interpreter fructs and arrays to a point. Let's upload that to the server. That's good, that's good, that's all gets saved. I'm going to program for the next more 10 minutes because I need to go get some sleep. My body clock is not adjusted yet. Thinks it's 1 o'clock in the morning. Right. What else could I do? I've got the external function calling, but that's going to take a long while. I'm going to have to properly think about that too. This is just a memcopy thing going on. Not tonight, not tonight. Probably more streams on... I have no idea. I can't do it tomorrow night. Unless I get my work done. I don't know. But yeah. Hello. Right. Is there anything else I need to do? Ah, that's one thing I might actually have to do. Is this. I never actually did it. Yeah, let's actually do that. It's a T32. I'm just going to copy and paste code here, by the way. I am not bothering. Doing it properly. It should work perfectly fine. So, and they should be switches. You could watch Undertale speedruns. What? What? No. There is not going to be a single piece of object-oriented programming in it. There's no orient in it. You can create those concepts if you really wanted, but it's not what is happening. Now, which of these will not work? Can you do knots in my language? Can I just check? I cannot remember. Okay, not remember. Whatever. Yeah, you can't do that. I thought you couldn't. You can do knots. No, you can't do a knot. Can't do a zor. Can't do an or. You can't do an and. You can do quotient. But I'm going to leave mod for now. So let's put them back in. And swap this to F64. This is a custom, what's it called, a custom colour scheme that I've made up. It's my own, so yeah. And also, that's not. Yeah, that's fine. So that's that. Vectors I'll have to do later. Comparisons I haven't done yet. But I could do comparisons right now. Let's see what comparisons I actually have. There's not many comparisons actually, come to think about it, so let's just do them. I'm still going to leave it there, but they're the only comparisons ones I actually have to worry about. It's okay. Another man's stream, okay. Whose other man's stream was this, by any chance? Is it Sean, by any chance? Or someone else? I have no idea. If it is, thank you, Sean. Whatever. Right. That seems alright for me for now. Oh, okay. That's nice to know. Oh, is it is it William Bundy? By any chance? I have no idea. There's so dozens of people here. So let me see. What else have I got to do? I've got bounds checking to do, but that requires me doing a call. Actually, I could do bounds checking now. Let's do the preload. Bounds check. What else do we need? We need 1, 2, 3, 4, 5 for that, but then there's 6 for the other. array add args arg file whatever. Let's just say instruction. Let's look at what bounds checking takes. They have a position and stuff, which is great. I haven't got a string making machine, have I? So exact value. Yeah, let's do that. Let's do it the other way around. Make exact value string. So this will be instruction instruction bounds check pos file BC index and length. Let's call the procedure. The procedure I'm going to call is, I need to find it first, and then whatever, like that. Okay. Fiery Drake. Nice chap. Very nice chap. Yeah. So, right. What we need to do now is I'm just going to do a lookup. So, lookup procedure. Just machine string name. Let's just do that. That should narrow that down. I don't know. To try and answer it. I'm not going to say how far it is because I actually just don't know. It's very far already. Is one way to put it, but yeah, that could mean anything really. Oops, VM value. Args. Oh, there we go. Oops, that's me being a numpty again. I haven't done comparison operators yet, so what I'm going to do is say they're all false. That's great, right? That's what you want. That's exactly what you want, right? go to, I don't know. Oops. A integer, which is also a boolean. Let's write 0. They're all false now. Oh no, let's make it all true. That's your hack. So that works. Let's look at the back. Can you start working on it? No. We can if you really want. The language, like, syntax has not changed that much. It's just I'm doing a lot of the cool, fancy malarkey crap. There we go. So when is 0.0.2? Actually, it's going to be 0.0.3. The next one is always 0.0. What? I don't know. I can't remember my conventions. It'll be ready when it's ready, and hopefully, touch wood, when is HandmadeCon? Hopefully before that, so people can try it. Yeah, hopefully before the 19th then. Hopefully. Yeah, you get used to not using Mouse. I only use mouse to do every other window. I usually do mouse as well because I'm lazy sometimes just doing that as well. I can actually do that without even... Like I can do it, don't even have to touch it, but it's sometimes easier. So the ray bounds checking done. We haven't done the comparisons yet, so that's always going to keep going hissy fitting at me. Quotients here going to have to do is to do take into account size of number. And oops, and signess. Yeah, I'm not. Yeah, that's fine. Okay, right. So let's do this. Yeah, don't bother. I won't bother until it's like really decent. It's alright so far is the best way to put it, but it's not done. Oops. Okay, so fine. Someone just followed me. Thank you, whoever that was. Certain that's not null. Otherwise, I'm going to run out of memory on the stack. I think, yeah. All right. Yeah, okay, thank you. By the way, you can do anything in C is the short answer. So shall I just disable this thing just to show you quickly what this thing actually does? Where is it here? So disable the interpreter completely now. So let's go to here and you know what? Comment that out for now. And let's just go import game.o main proc. I actually didn't touch this thing in a while. Does that work? Yeah, it still works. See? There's OpenGL demo of a thing I'm controlling with my arrow keys. It's working fine and dandy. There you go. Does that resize? No. No, it doesn't. I didn't set it up to do that. But yeah, look, it moves around. Close it. Works. There you go. You can do that. That's one little cool thing. Yeah. But I'm just working on everything else at the moment. So if I run this, it'll go have a hissy fit me and like, we haven't got everything working yet, guys. That's what it's trying to say. It's like, yeah. So let's not do any of that. And that would actually, that's already showing loads of things we haven't done yet. So right, if you're going to do if you're still learning programming, do not learn this language. It's not meant for learners, beginners at all. I would suggest learning C, or you said you're learning Rust. That's fine. Just sit with one language for the moment and learn it. I mean, learn it and practice and make sure you can do stuff in it as well. So this is not for beginners by any stretch of the imagination. There's a lot of high-level complicated concepts in this language. So please just, if you can, don't. Yeah, fine, I'm not a big fan of Rust, by looks of it for me, but that's why I'm making a new language. But again, I know a lot of people who like Rust and say it's good for them. But it's fine, do whatever you like. Everyone's an individual. You're all individuals. Okay, I'm gonna go pretty good. This is pretty nice. VM lookup procedure. Let's just make that a little bit simpler. There we go. Let's just say, where's the comparisons here? Make that a new line. Oh yes, if you noticed it, by the way, I spent about like 30 minutes the other day making a tokenizer for the actual language to see if it actually worked. It kind of works, but yeah, it's quite simple as well. Full code is just another text editor. I'll put a link in the. Have we got Insobot on this stream? Yeah, thank you. Okay, you don't have to do that then. Where is it? Token strings bo op literal. There we go. That's good. So I think there's no difference here. It's going to be a bitcast. It's the same actual thing. Doesn't matter. Yeah. Okay, so I'm going to stop now, right now, and thank you all for watching. I'm just going to make a little comment before as well. we go. Just come here and push this